Welcome to qnawire.
So in this last problem, we have another cable that is spanning these two points here. We're not told how far apart they are. We're told that the cable sags 3 meters though, and we're told that it weighs 10 newtons per meter, or 10 kilograms per meter. And we're told that the maximum tension that we can have in this cable is 1,500 newtons. So again, our position is given by this expression, and the S, the arc length coordinate, where we are on this cable as a function of where we are horizontally, is given by this expression. We also know that the tangent of this angle here is the derivative of this at x equals at whatever distance this is. Right, so we have then that, and again I'm gonna call this total distance here d. So this distance is d over 2. So then this gives us an equation. We can then use this expression and figure out what the cosine of this angle is, and then figure out that the tension at point B or at point A is given by this expression here. And that will be our maximum. And if we have a maximum of 1,500 newtons, we can use this equation here. We can invert it and get D as a function of FBX. It's a lengthy, ugly expression, and I'm not going to reproduce it here. But anyway, we can get D as a function of FBX. Now, we know the sag is 3 meters, so Y at D over 2, which is just given this expression here, needs to be 3 meters. We can then take this function here and plug it into here and get a very, very ugly expression, but an expression in which the only unknown is FBX, the horizontal load. And we can graph it and numerically find the solution to that, and it says that FBX is 1,210 newtons. We can then plug this back into this function, and we'll find that D equals 16.8 meters. So we have to have, we can't have this any greater than 16.8 meters. Otherwise, we'll have greater and greater tension in the or horizontal, greater and greater tension in the rope or in the cable. So we can't stretch it too much, basically.